Hello and welcome to a comparison of the types and topologies of firewall systems by Robert Duffer. Let's start with the definition of firewalls. Firewall controls the flow of data between two segments of a network. The firewall is the gatekeeper between the outside network and our trusted network. They provide the first level of defense for the devices that are under our control. They are typically the devices at the highest risk and the most exposed location. As such, they perform a critical function as part of an overall security plan. Firewalls were initially designed to guard against network misconfigurations and to protect bandwidth from chatty protocols. Initially, there were not a lot of threats on the internet, and the biggest problem was misconfigured networks taking bandwidth or causing other problems. But firewalls were designed to prevent known threats, as system intrusions and worms in the 1980s galvanized this need for better network border protection. The internet and local area networks became more valuable over time, and they also became bigger targets. The development of worms, trojans, and viruses led to this need for a gateway between the trusted network and the less trusted networks. This gave rise to a single-purpose, standalone device that could be hardened to handle the initial contact with the outside world. Over time, firewalls have matured and generally developed along the layers of the OSI model. One of the first firewall technologies was MAC filtering that worked at the data link level. MAC filtering looks at the specific address of the machine requesting to enter the network and looks up against an existing list and decides whether it's authorized on the network or not. This is a fairly simple type of technology to get around by doing MAC spoofing, so it's not a highly recommended methodology anymore. Packet filtering technology, on the other hand, is still very common. It looks at the sending device and the destination device and even the protocols that are being used and determines whether they make sense and that this is some data that should be accepted into the network. Stateful packet inspection takes that a bit farther and actually looks at the entire conversation and keeps track of the entire conversation from the requesting device to the server and back. Because it's keeping track of the state of the packet, it's a little more CPU intensive, but it can determine quicker whether this is a valid part of an existing conversation or an invalid type of data to discard it. It works at the transport layer. A little more CPU intensive, but can be a little faster and a little more secure. The next generation of firewall technology would be the application proxy or gateway server. An application proxy stands in place of a server and can sit in front of the firewall where it's at a little higher risk, but it's protecting the actual server that's still behind a firewall. An application proxy takes the request from the outside and examines it, and then if it considers it a valid request, will go through the firewall to the actual server to retrieve data to send back to the requester. An application proxy is at a little more risk, but in some cases it can speed up and provide a more hardened device than what you'd be able to do with your server. A very common application for this would be web serving, where you don't want to put your database in front of the firewall. You'd rather have the application proxy in front of it, making requests back to the server in its safe place on our trusted network. Deep packet inspection looks at all parts of the packet, the header and the data itself, to examine it for viruses and trojans and other different threats that might be encased in it. Deep packets inspection is probably the most secure firewall that you can use, but it is a slower and more CPU intensive firewall. Let's take a look at firewall forms. Firewalls typically come in three forms, the first being software only. In this case, the software or the application will be installed on a device that already has an operating system. Some examples would be Zone Alarm, McAfee, or Online Armor, and hundreds of others. In some cases, it could be an application within the operating system, like Windows Firewall, or bundled in a suite, or standalone. There's open source, there's freeware, there's shareware. One of the disadvantages of doing something like this is that you're going to be running that on an operating system that may have multiple vulnerabilities in and of itself. This puts your firewall at risk along with the data you're trying to protect on your machine. These typically are not to be considered a network firewall, but really a personal firewall, since it only is securing the machine that it's running on. The next type of firewall form is software combined with hardware. So this is generally a standalone device that runs the firewall service and stands in front of your router or your PCs or the network that you're trying to protect. Checkpoint, Cisco, Barracuda, and Fortinet are four of the large vendors in selling standalone firewalls. These devices can be very simple, like a PIX 506, all the way up to some very complex models that get very pricey. But these are more effective and at a higher level able to protect an entire network, and in many cases even networks that span multiple locations. One other option that's fairly new is software as a service, that is network-based firewall services. Some of the large telecom operators provide this, like AT&T and Verizon and Paytech. In this case, you don't deal with the physical firewall yourself, but you're actually renting a service that somebody else is taking care of. Generally, these are only available on an MPLS network, but one of the advantages, it prevents the bad traffic from even hitting your port onto the network or your pipe getting you to the network. It doesn't remove the planning and monitoring steps of a good security plan. You still have to be sure that you only have a single entry point onto your network and that the firewall is that single point. Here's a couple topologies to look at, firewall topologies. The first is the bastion host. In this case, it's fairly simple and straightforward. The firewall sits in front of your trusted network and all internet traffic passes through it to your trusted network. This is typically only used when you have a very simple system. For instance, if you're not providing any internet service to the internet, but you're just providing security for your trusted network, this is a very simple, straightforward way to set things up. About the only application that works well on this would be a VPN that you're using as access, but web hosting or FTP or some of those other services would probably be better used for something besides this particular topology. For example, a screen subnet uses a firewall that is dual homed, or can set aside part of the subnet for a DMZ or demilitarized zone. In this zone you would set application proxy servers or other devices that were hardened and more secure for dealing more directly with the internet. This is really a nice and a fairly simple way to set up your network and is very common. This allows some machines to be in a less trusted but more accessible state to the internet and still keep your network very secure. To raise your security a little bit further, you could put in dual firewalls. In this case, you have an independent firewall in front of the DMZ and another one behind it in front of your trusted network. This gives you two different places to protect what traffic comes into your network, and if you were utilizing different vendors for those firewalls, you would even have a more secure network because a single vendor-specific vulnerability would not allow somebody all the way into your trusted network. So a dual firewall is a very secure way to set things up. Now let's take a look at three of the functions that a firewall must provide. Those three functions can be remembered with CIA. The first is confidentiality. Knowledge is becoming a key asset. Stored data can have a high liability risk on our network, so we must prevent disclosure or exposure of our intellectual property. In doing that, we're securing the document storage network to be sure that it is a safe network for keeping our intellectual property on. As part of that confidentiality, we need to be sure that our firewall is applying the security policies. A little note on that: it's more important to plan a good policy to have your firewall perform that than it is to have a good firewall with a poor security policies. So start with a good plan. If there's holes in your plan, there's probably going to be holes in your implementation. The next thing that a firewall needs to do is provide integrity. Integrity is the confidence that the data and the information on your network is secure and is not altered. We have to have confidence in our trusted network, and the firewall is an instrumental part of that. Beyond the integrity in the network, we must have integrity in the security policy and its application. The security policy has to be designed well, with covering all the things that need to be covered, and any hole in it will be a hole in the integrity for your network. Third, under integrity is the integrity of the firewall. You have to be confident that it is performing the function it's designed to perform. Therefore, you're going to be checking its health often. It's a high-risk device. It's a frontline soldier. You need to be checking its logs and making sure that its configuration has not been changed. The third thing is availability. You have to allow the flow of data and do it safely. Business needs information like the body needs blood. It can't be restricted from where it's needed, but it must be limited to where it's supposed to go. Firewalls can be used to prevent exposure disclosure both outside and inside. Using firewalls between VLANs can protect data further and give you layers of security from less secure to most secure. There will always be some kind of balance between security on the network and access to that data, and it's a never-ending battle and something that almost always needs adjustment. Some best practices. First off, plan first and plan thorough. Your overall plan is really what protects you, not a single device. You need to know the role of each piece of hardware, and you need to understand your network so that you can configure your security to meet your actual needs. You can expect to be changing your systems. It's part of the game of security. Monitor, adjust, and test. Network design, firewall configuration, and network monitoring should also be part of your plan. Multiple firewalls present extra complexity but can offer considerably more security. You need to monitor your firewall closely and update it routinely. Use access control list tools to be sure the rules are consistent, complete, and compact. Keep the firewall and all parts of the security policy up to date. Keep a log of any changes both to the firewall or to the security policy, so it's easy to audit and see where things need to be tested. Use intrusion detection, host-based firewall, content filtering, and many other services in conjunction with your firewall for maximum security. In conclusion, firewalls are a key component of an effective security plan. You need to identify your needs for security and access both now and in the future, and then select the technology that you need. Firewalls need regular expert attention to provide maximum benefit. Neglect that and you're risking everything they protect. You need to make sure you know what you need and what you think you will need. You're not buying a device, but you're committing to a technology that will need to be modified, maintained, and developed. Knowing the product will be supported, both hardware and knowledgeable expert, is a key to keeping your data safe. A firewall is not set and forget. Monitor your logs, check your status, keep tabs on configuration changes. It's all part of the never-ending process of securing your data. I hope you have enjoyed and learned something from this. Thank you.